right, so let's take a look at finding trig ratios when you're given another ratio. Okay, so that's two major things that you need to know. The first one is trig ratios and the reciprocal. So let's fill this out. SOHCAHTOA is opposite, so across from the angle, that's opposite. Then hypotenuse, remember where he pees, right? So his legs and where he pees, that's h, and whatever else is left is a. So sine is opposite, which is y, over h, which is r. Cosine is adjacent, so a, which is x, over r. Tan is opposite, so that's y, over x. You do also need to know the inverses. Let's start with secant. Remember, you read that backwards, that's cosine, so the inverse of that. And then cot is tan, so cosecant is sine. And all you're doing is flipping them over. So x over r is going to be r over x for cosecant, and tan is going to be x over y for cot. All right, so it's just the inverse. It means you're reciprocal. You just flip it. All right, so let's take a look at the second thing you need to know. Where is the trig ratio positive or negative? So remember, you have the x-axis on the horizontal line and the y-axis on the vertical line. This is a listening check. Color in sine of theta. So sine of theta, remember, is y over r. So the question is when is y positive? So that's the x-axis and that's the y-axis. When is the y-axis positive? Okay, so I'm just going to cover up where it's negative. So positive is up here, right? So it's in these two quadrants. And again, you go 1, 2, 3, 4 counterclockwise. So it's in quadrant 1 and 2, y is positive. When is it negative? Well, it's negative in the other ones, 3 and 4. So again, when is negative? 3 and 4. All right, cosine is x over r. So when is x positive? All right, so when's the x-axis positive? It's positive in quadrant 1 and 4. And when is it negative? On the other side, which is 2 and 3. All right, when is tan positive? So remember, tan is y over x. So for it to be positive, it either have to be both negative, because negative divided by negative is positive, or both positive, because positive divided by positive is negative. So I'm looking for the same sign for y and x. So when is y negative? Boom. When is x negative? Boom. So quadrant 3. So that's giving you negative, negative. All right, let's look for positive, positive. When is y positive? And when is x positive? So quadrant 1. So tan is positive in those two quadrants, which means the other two quadrants, it's negative. All right, so you don't really have to remember that. All you have to know is all students take calculus. All students take calculus. So the T is for tan, the C is for cosine, all is for all of them, and then students is sine. This is a listening check, color in calculus. All right, so let's take a look at an example. So you're given one and you ask to find another. You first have to identify the quadrant. So cosine, when is cosine positive? Well, it's positive in two places, all, where they're all positive, and where it's just calculus. So quadrant 1 and 4 is when it's positive. And we're going to represent that in a graph. So grab some colors, two different kind of colors, I'm going to color that in. So quadrants 1 and 4, you're going to color in one color. So I'll do red. And then when is tan less than 0? What does that mean? When is it negative? So when is tan negative? Well, tan is negative when it's not positive. So it's positive in 1 and 3, so it's negative in 2 and 4. So color those in. Wherever the intersection is, that's the identifying quadrant that you're looking for. So we're going to draw a line in that fourth quadrant right there and make a triangle. This is a listening check. Color in that triangle. Remember, you start from the initial side to the terminal side. All right, so we're looking for cosine theta, right? Remember, cosine is adjacent over hypotenuse. So we need to start labeling our fraction, and then we need to label our triangle. So let's label this theta right here. Okay, remember, you're going to draw your man, right? There's his head, there's his hands, and he's peeing on the hypotenuse, which is also the radius, which in our question is 13. Then we're going to go across from that, that's opposite, which is the y value, which we don't know what it is. And then the only other left is adjacent, which is our x value, which is 5, according to the fraction. So now we need to use Pythagorean theorem to find out what y is. Pythagorean theorem says a squared plus b squared equals c squared. So to find c, it's the hypotenuse, so that's 13. And then the order of a and b doesn't matter. So 5 squared plus y squared equals 13 squared. All right, we're going to subtract 5 squared from both sides. So that'll be 13 squared minus 5 squared. Square root both sides. So now I'm going to have y equals 13 squared, which is 169, minus 5 squared, which is 25. then that's going to be square root of 144, which is equal to 12. Now, because this is going down, it's negative 12. So be very careful to look at the direction of x and y. So y is equal to negative 12. All right, now let's write the ratios. So sine of theta we know is opposite over hypotenuse. So opposite would be negative 12. Hypotenuse would be 13. So negative 12 over 13. That's my ratio. If I was to write tan of theta, it would be O over A, opposite over adjacent. So opposite is negative 12 again, and adjacent is 5. So my ratio is negative 12 over 5. And I can find anything. So it's even if it's not here, let's find the inverses. So let's find cosecant. So cosecant of theta would be that inverted, so negative 13 over 12. Flip it, the reciprocal. Cot, remember, is the reciprocal of tan, so just flip it, and it's going to be negative 5 over 12. And since we have cosine, we can find secant, which again, flip cosine would be 13 over 5. So it doesn't matter what they ask you for, you can find it. All right, let's take a look at another question. So again, you always start off by identifying the quadrant, okay? So all students take calculus. When is cosecant positive? Well, cosecant is not my diagram, but we know cosecant is the inverse of sine. So all we gotta do is flip the fraction and that will be sine. For right now, we can leave the rational on the bottom because we're only just trying to see what quadrant it is. And it's positive, right? So when is sine positive? When it's all of them or when it's students. So in quadrant 1 and 2, again, take a color and shade that in. And then also your second condition is tan must also be positive. So when is tan positive? Take a second color. When is tan positive? All, and also in quadrant 3. So shade that in. The intersection of those two colors is where you're going to draw your ray. So let's go ahead and draw that. I'm going to make a triangle by coming directly down to the x-axis. All right, and then we're going to label this triangle. So again, draw your man. He P's on hypotenuse or C if you're doing Pythagorean Theorem. So that's H, which is also equal to the radius. Opposite would be Y, which we'll fill in a second. And whatever is left over is adjacent, which is X. So let's see what we're given. We're given sine. So SOHCAHTOA says sine is opposite over hypotenuse. So 4 is the opposite. So I'll label that. And hypotenuse is radical 65. So now we just have to find adjacent. So to find adjacent, step 2 says we're going to use Pythagorean Theorem. So again, write it out, okay? So definitely write it out. This is a listening check. Color in 1. So a squared plus b squared is c squared. What's my c? Radical 65, and the rest doesn't matter. 4 squared plus x squared equals radical 65 squared. So subtract 4 squared from both sides. You're going to get, well, what's radical 65 squared? Just 65. Minus 4 squared, which is 16. All right, take the square root of both sides. You're going to get x is equal to the square root of 49. And what's the square root of 49? 7. Now, because this is positive x, that 7 is positive. So be mindful to know which direction of the x or the y-axis it is. And finally, step 3, write all the ratios. So tan, opposite 4 over adjacent 7. Cosine, a over h. So adjacent 7 over h, radical 65. And we can't have radical 65 on the bottom. So what do? Rationalize it. Multiply top and bottom by the radical. So you're going to get 7 radical 65. And the radical times the same radical is just the number inside, so 65. All right, and again, those are the only ones we found, but we're going to go ahead and find the inverses as well, or the reciprocals. So let's do cot, because that's the reciprocal of tan. And all you got to do is flip it, so 7 over 4. Then let's find secant, which is the reciprocal of cosine, which you flip it is just going to be radical 65 over 7. And that's how you use one ratio to find the rest.